Hey, what's up, guys? Mr. Cruz here to give you guys the next rundown on our next unit, which is going to be box plots. So this is I'm gonna call it box plots because that's what I grew up calling it. But they're technically called box and whisker plots, or like they can be both, and you'll kind of see why. When you see it, it just makes sense. All right, so trust me. All right, so this stuff is not really all that complicated. The big reason that we use box plots or box and whisker plots is whenever we want to take data. So like, let's say we wanted to measure the height of every student at school, but we wanted to arrange all of the heights into quarters. So we wanted to have each section show us like, what does 25% of the students' heights look like? Might sound a little complicated, but like you'll kind of get the sense of it when we go over our examples here. All right, so box and whisker plots. Yes, they it's a diagram. It's just like any kind of other graph that we use. Different graphs have different reasons that we would use them. Like, for example, line graphs are good when you're trying to track data over a set of time. Um, Bar graphs are good when you're like, I don't know. I mean, we'll get to that stuff later. But box plots, whisker plots is for when you want to compare things into four parts, into quarters. All right, so let's go ahead and do this right here. So the four parts that we're talking about when we're talking about our box and whisker plots are the upper, lower, and upper and lower quartile, and then the upper and lower extreme. So we'll explain what all that means, but just know that mainly these parts right here, the upper and lower quartile, are the ones where you're really going to have to find. That's where you're going to be using math, right? That's where you're going to be adding, subtracting, and all this, and multiplying and dividing and things like that, in order to find the upper and lower quartiles. Right now, it doesn't mean anything, but don't worry, we're going to get to it. All right, so let's go ahead and keep it going. Come on, yo. Bam. All right. So think about the word quart or quarter, right? When I think about the word quarter, I usually think of like something like money or 25 cents. Or if you're talking about stuff like pizza, right? If you cut a pizza into quarters, you're cutting it into 4 slices. So when we think about it in terms of something like a liquid, right? 4 quarts equals 1 gallon. When we think about it in terms of money, 4 quarters equals $1. In terms of football, 4 quarters equals a whole game. In terms of business, right, 4 quarters equals a year, because businesses track things over the course of an entire year. And when they break it up into quarters, they're really breaking it down into 3-month periods, because 3 times 4, right, the 3 months per quarter times the 4 quarters that we have in a year equals 12 months. So same thing with box and whisker plots. We're breaking things up into quarters, into 4 equal or 4 even pieces. All right, let's keep it going. All right. So because of the word quart or quarter, we use the word quartiles, and quartiles in this case just means a group or a section that represents 25% of the data. So right here is where we see the words quartile. So when we talk about the upper quartile or the lower quartile, we're talking about like the upper 25% and the lower 25%. Now, that's going to be different because we also have lower and upper extremes, and we'll kind of get to that when we get to that point. But just understand that for this part, quartiles means 25% in this case. When you see that section, that's what it means. All right. Now let's actually work on plotting it, because I'm sure that once we plot it, it'll make a lot more sense and you'll kind of understand it easier. All right. So we're going to start. I'm going to give you guys on the next slide, I'm going to give you guys a set of data. What we're going to start out by doing is finding the median of that data. If you remember, the median is just a fancy word that means the middle number, or like the middle. And in order, I'll show you guys how we can find the median. But for now, just know we're talking about the median. To find the median, we're going to find the median of the upper half, which is going to be our upper quartile. And then we're also going to find the median of the lower half, which is the lower quartile. Don't worry, this is a lot easier than it sounds. Even explaining it, I feel like it sounds complicated. But trust me, it really isn't. It really isn't. It's just sometimes you just got to say things. You know what I'm saying? All right. So we're going to be comparing this right here, which is some dude named Ben. And the percentages that he's gotten on the last 10 tests that he's taken. So the first thing we're going to do is we're going to put the data in order from greatest to least. Wait, no, that should be backwards. from least to greatest. And doing this is going to help us to be able to find our median to start out with. So luckily for you guys, Mr. Cruz is big brain, but I would ask for you to stop, pause it, and then arrange those numbers into least to greatest or an ascending order before you move on. Okay, ready? 1, 2, 3, pause, go do it. Why are you still watching the video? I told you to pause it. You just want to kind of skip ahead because you know that I'm going to end up doing the example for it. No, stop and do the work yourself. Put it in order. All right. And 3, 2, 1. All right, we're back. And then I have arranged it and I've got it written here on my desk. So the median is going to be the middle number. Now, unfortunately, we have an even set of numbers. So that means if we split the numbers down the middle, we're going to end up with two numbers, 80 and 85, which, 80 and 85. All right. And then those two numbers, our median would be somewhere in between them. So what we're going to do instead is we're going to add those two numbers together and we're going to divide it by 2. So 80 plus 85. And then whatever our answer is, we're going to divide it by 2. I know that when I divide it by 2, I end up with 82.5. So 82.5 is what my median is going to be. Now we need to find the lower extreme. And our lower extreme is, all that means is just the lowest number that is on that list. So if we arranged it in order from least to greatest, I know that my lowest number is going to be 65. I can go ahead and do my upper extreme as well, because guess what? Upper extreme is going to be the highest number. All right. And our highest number is 105. All right. Now it comes to the hard part, because I have the lower quartile and the upper quartile that I got to find out. So I need to split the numbers right down the middle. And when I split that number right down the middle, again, if you have arranged it in order from least to greatest, you're going to take all the numbers that are lower than 80 and all the numbers that are higher than 85. All right, that's how you're going to split those up. So if I did that correctly, then my lower numbers are going to be 65, 68, 75, 77, and 80. All right, that's in order from least to greatest. I need to pick the middle number. So luckily this time I have 5 numbers. So I can just pick the 1, 2, 3, right? The third number, because that third number is going to be my middle number. So that's going to be my lower quartile. So 75. So 75 is going to be my lower quartile. Now with my other set of numbers for the upper quartile, I have 85, 86, 89, 95, and 105. So I need to pick the middle number in that list, which is 89. All right. So I have all of my data. I have my lower and upper quartile and my lower and upper extreme, as well as my median, right? My median number. So let's go on to the next slide. Now what we're going to do is we're going to graph these numbers. Finding them is not hard. Graphing them should be even easier. All right. So we're going to graph the numbers. We're going to start out by graphing the median and then the quartiles and then the lower and upper extremes. So once I do that on my number line, this is what they should look like. Now, the next thing that I'm going to do is I'm going to draw a box around the quartiles, not the median, just the quartiles. So that pretty much means I'm going to take this right here and make a box, right? Because the number that's in the middle, that green number, is 82.5, which is my median. So for that one, I'm just going to draw a straight up vertical line in between it. And 65 and 105 are the only two dots that are left on my number line. Those are my upper and lower extremes. And all I'm going to do there is draw some whiskers out to them. And then that's kind of how we end up with a box and whisker plot. Now, why is this significant? Is because this section right here represents 25% of my data. This section right here also represents 25%. That right there represents 25, and that represents 25% of my data. So if I have information, data, height, ages, number of siblings, favorite color, anything, I can arrange it like this to have a quick glance to see what does 25% of each section look like. Now, moving forward though, we also have something called an outlier. So let me see, we did, okay. All right, actually, no. Before we do outliers, we're going to do the inner quartile range. So the inner quartile range just means that we're taking the difference right? We're just subtracting the lower quartile from the upper quartile. So we're just taking those two numbers and then subtracting them from each other, right? We figured out that it was 89 and 75. So I'm just taking 89 minus 75. That equals 14. 14 is my interquartile range. All that means is that there's a range between those two numbers and it's only 14. I know that sounds super ridiculously. You guys understand what range is, right? We're taking like how much is it between like the smallest number to the biggest number. But in this case, since we're only talking about the quartiles, we're just taking the lower quartile, subtracting it from the upper quartile. And then that's it. Or yes, taking the upper quartile, the lower quartile and subtracting it from the lower, what? No, taking the upper quartile, taking the lower quartile. Put the bigger number first. That's all I mean. Jeez. I'm struggling today, y'all. I'm not going to lie. All right, last thing that we're going to go over is something called the outliers. So the outliers is whatever is 1.5 times the interquartile range from the quartiles. This one kind of gets a little bit, you're not going to focus on this a whole lot, but I do want to make sure that you guys understand and know how to do this, but you're not going to see it a whole lot. So I realized that my upper quartile is 89, and then my lower quartile is 74. You understand why I'm struggling, right? This is clear indication. My lower quartile is 75. So we figured out on my last slide that my interquartile range is 14 because of math, right? So what I'm going to do is I'm going to take 14. You see my step right here. I'm going to take 14 and I'm going to multiply it by 1.5 and I end up with 21. So my outlier is going to be taking my upper quartile and I'm going to add 21 to it, right? So I'm going to take 89, add 21, and I end up with 110. I'm going to do the same thing with my lower quartile. Take lower quartile minus 21 this time, right? Because my lower quartile, I need to find out what's even further below it, which means what would be even more to the left, which on a number line, if we're going to the left, that means we're subtracting. So I'm going to do 75 minus 21, and I end up with 54. So outliers, all they mean is that any number that is below 54, any number that is above 110 is going to be considered an outlier. That means that it's way too far outside of the 25% range of the upper extreme and the lower extreme that we're not going to kind of count that as part of the 25% that we see when we break it up into quartiles. So we're going to plot this using a dot. We're only going to plot the outlier on the top, but still, even in this case, right, when we go all the way back, and look at my dude Ben's data, right up here, he didn't score anything above 110. He didn't score anything below a 54. But we're going to make believe like he did, and let's say that we're going to plot that as the outlier. And then over here, I guess 54 would be somewhere around here is where that lower outlier would also be. So there you guys go. This is what Boxplots entails. I get that it was kind of weird and complicated, but I'm going to give you guys another video showing you guys how to do the IXL. But good luck on this stuff. Again, the hard part is really this stuff right here. I'm going to go back to it. This stuff right here. Finding out what the upper quartile and the lower quartile is. That's the most math that you're going to have to do. Finding a set of numbers, which one is in the middle? Okay, you split those numbers down the middle. What is the middle one on the lower side? What is the middle one on the upper side? And that's like 90% of the work. All right, I'll see you guys later. Hit me up if you guys need any help. Peace.